Arjun, and this is my presentation for the sliding window coding challenge for UPE. So what is a sliding window? It's a programming technique of using pointers to focus on a subarray. So you can modify the window if the problem's criteria is not met, depending on the problem, and we'll get into a few examples of problems in the next slide. So the overall goal is you're looking for the best window, and that will be your final answer. And the advantage of using a sliding window as opposed to a brute force solution is the better time complexity that it offers, usually O of n, offering a linear time complexity. So when and how should one use a sliding window? So in a problem, when you're given an array and you're asked to find some subarray, so some key terms that you want to look out for in sliding window problems or problems in which you might be able to use a sliding window are maximum, minimum, or you're looking for a number of different subarrays that match the problem's criteria. So when you're implementing a sliding window, a few things you want to consider are the number of pointers that you are going to use, as well as their purposes, and also when you want to shift, shrink, or expand the window. So when you want to modify the window in any way. The most common pointers are one for the start of your window and one for the end of your window. However, there are more advanced problems with 3 pointers. So when it comes to the end pointer, it is generally the variable that is being used in the for loop or the while loop or whatever you're using to iterate over your array. So that will be updated at the end of every iteration of your loop, while the starting pointer can generally be the one that you're modifying only under certain circumstances. So only when that is met, when some condition is met, that's when you want to shift, shrink, or expand the window. And another thing to remember is that you want to compare your current answer. So whatever if you're asked to find the maximum length of the subarray, then you want to continuously check your current maximum length of the subarray with whatever your current window is. And if your current window is larger than your current answer, you want to update your current answer. So here's a problem just to demonstrate the difference between a brute force solution and different optimizations you could perform on this brute force solution to adapt it into a sliding window solution. So in this problem for maximum subarray, you're asked to find the contiguous subarray within an array containing at least one number which has the largest sum. So in this example, you're looking for the continuous subarray 4, -1, 2, 1 to get you the largest sum of 6. So the brute force solution in this case would have a time complexity of n cubed because the outer loop would be to find every starting position of your subarray. The next inner for loop or the next inner loop would be to find every ending position to accompany that starting position, and the furthest inner loop would be to loop through between the designated start and end indices and calculate the sum while going through them. So that would be O of n cubed, but a few optimizations you could add to this solution to turn it into a sliding window one are you can go through and for your window, you can just see what the running sum is. And when the running sum hits a negative number, that's when you know up until this point, we no longer want to use this because it has a negative value so far. So you can have a start pointer and the end pointer. And as I mentioned earlier, the end pointer can be what is looping through. So that's the variable that we're using in our loop. And so that increments at the end of every iteration, and we can move our start pointer whenever we find that our running sum has hit a negative value. So that's the condition that's the condition for which we want to shift our window. And that would give us a linear runtime, as opposed to the O of n cubed runtime that we would have from our brute force solution. So here's an example problem for sliding window that we can use. So we're trying to find the longest turbulent subarray. So given an integer array, return the length of the maximum size turbulent subarray, which basically means the comparison sign between each adjacent pair of elements changes. And so a few things we want to consider when implementing or when thinking about how to implement this sliding window problem are how many pointers do we need, and how and when should we modify the window. So one of the most common ways, as I mentioned a few times, for how many pointers we need are 2 pointers, one being the start of the window and one being the end of the window. So the end of the window will just be incremented in our for loop, and the start of the window we can increment when our certain condition is met, and I'll discuss that in the next slide. And how do we want to modify the window? We want to modify the window underneath that same condition. So I'll pull up the solution, and I can walk through it to explain both of those main topics. So in this case, as you can see, we're given our integer array called r. So here our counters, our pointers are going to be x and y, which refer to the start and end indices respectively. And our answer, which is going to be our running best maximum length of the window, is going to start off at 1. So we have a left difference and a right difference, and that's to account for the fact that, as we see here, the comparison sign should flip between every adjacent pair of elements. So if the left pair of elements is the left is greater than the right, then for the right pair, it should be the left is less than the right. So here we have a left difference and right difference, and that's what it's accounting for. So we loop through our length of the given array, and as I explained, the end pointer, y in this case, is going to be in our while loop, so that's what's going to be incremented at the end of every iteration, regardless of what happens. So we calculate our right difference by just subtracting the right element by the left element. And an interesting thing to note here is that instead of the way that we can account for the flip-flopping of the different comparison signs is by checking what the product of the left difference and the right difference is. So since we know that, say for example, the first number is 2, the next number is 4, and the next number is 1, that means that follows that 2, 4, 1 is a turbulent subarray, and we can tell that using this left difference and right difference by noticing that since they flip-flop, the product of the two differences must be negative if it's a turbulent subarray. So here we check if the product of the two is a positive value, then that means we want to shift over our window. So we're setting our start pointer equal to our end pointer minus 1, because our end pointer minus 1 can still be included in the next window. So it still is unknown whether it's met the criteria to be a turbulent subarray from that point on. Else if that's not the case, and if our right difference is 0, meaning that our array's element at index n minus 1 is equal to our array's element at end, then since they're both the same value, that doesn't meet the criteria for being a turbulent subarray. So instead of starting moving our start pointer to be end minus 1, we move it immediately to be end, since we know that end and n minus 1 are the same value. And then we update our left difference to be our right difference, since now we're going to shift everything over because we're moving through an iteration of a loop. And here, as I mentioned, an important thing is to compare our current running answer and see if our current window is better than our current answer. And if that is the case, then you want to update your answer. So that's what line 12 is doing. And finally, we're just incrementing our end pointer. And after this whole process is done, then we return our running answer, which by the end of the program will be our final answer. I hope this helped with your understanding of sliding windows. Thank you for your time.